Alright, now for this question, for question tutorial 1 chapter 1, where question number 23 from workbook, which question A, many of you asked me this question. So the question asks you, or given you, the function of fx and gx and hx are defined by fx equivalent to square root of x square minus by 1 plus by 1 over by x, and gx given is x square minus by 2, and hx is x over by x plus 1. And they ask the question, find the value of the following. A, find f composite gx and its domain. So first what you do is that you do the composite of f composite gx, which give you your inner function is gx. Alright, so f gx, basically substitute your f function with x square minus by 2, and you're gonna get x square minus by 2 square minus by 1, and then square root everything, plus by 1 over by x square minus by 2. And then you can simplify. You're gonna get x power 4 minus by 4x plus 4x square plus by 4, and then minus by 1, square root everything, plus by 1 over by x square minus by 2. Then you can get this one can be written as such: x power 4 minus by 4x square plus by 3, square root everything, plus by 1 over by x square minus by 2. I think this is the simplest that you can get. So this is your f composite of g. Now the second question they ask is to find the domain. Alright, now remember that domain for composite function, you have to check your domain of your inner function, and then you intersect with the domain of overall. Okay, basically your domain for inner function here is domain of g. Now if you look at domain of g over here, basically it's just a polynomial function, which is quadratic function. So you have negative infinity until infinity. Okay, no problem. Now how about the domain of overall? Now the domain of overall over here is quite a lengthy domain. You can look at here, it will be a lengthy things to do. The first term you have a square root, so you have to check under the square root should be greater than equivalent to 0. And the second term you have a rational, so your denominator cannot be equivalent to 0. So let's do one by one. Now domain for overall, there are two parts. The first part is that under the square root should be greater than equivalent to 0. So you have to check lah. So over here would be x power 4 minus by 4x square plus by 3 greater than equivalent to 0. And the second one is that the denominator cannot be equivalent to 0, where you have x square minus by 2 cannot be equivalent to 0, which is much easier to solve, which give you x equivalent to plus minus square root of 2. Now for the part you have inequality, now this is fourth power, but you have three terms that you can actually factorize your fourth power, which give you x power 2 multiplied by x power 2, which give you x power by 4. And you have 3 over here, which is the product of 3 and 1, which basically if you actually put negative 3 minus by negative 1, you will have negative 4. Alright, so the sum of it. If you don't know, you can always let. Alright, you can always let's say the term of m equivalent to x square. So x power 4 will become m square, which is x square square. Alright, so you can have m square minus by 4m plus by 3 greater than equivalent to 0, which you get the same thing, x square minus by 3, x square minus by 1 greater than equivalent to 0. So this is one thing you can do it. Alright, but I can just simply factorize, so I just factorize. Okay. Alright, now just now I didn't show you actually what I did over here is actually if you factorize, okay, I'm showing it here. So m square minus by 4, m plus by 3, you can actually put it in factored form. You can use your calculator. So m multiplied by m, 3 and 1 minus minus. And then you substitute back your m with your x square, which is this one you did before. Alright, so it will be x square minus by 3. And then this one will be x square minus by 1, which should give you here back. Alright? Okay. Then, what happened is that these two factors, can you still factorize it? You can, because this is in the form of you can write it as in the form of a squared minus by b squared, where you're gonna get a minus by b, a plus b. Alright, now over here your a is x, so x. Your b is actually a square root 3, so minus by square root 3 multiplied by x plus square root 3. And this you're gonna have x minus by 1, x plus 1 greater than or equivalent to 0, which you have 4 factors. Once you have the 4 factors, how to solve it is you can do the sign table. Alright, do the sign table, which leave you with, so you have x minus by set 3, x plus by set 3, x minus by 1, and then you're going to have x plus by 1, and the last part will be your resulting sign. Okay, so over here, so you have 4 factors, mean 4 zeros. So you have the first 0 you're gonna have is set 3 minus set 3, 1 and minus 1. Which one is the smallest? The smallest is negative set 3, and then come negative 1. So you do it your real number line increasingly, you're gonna get minus 1, here is 1, here is set 3. Okay, now then put the sign. So you have this factor, the zeros is set 3, so after that you get plus. Alright, now the rest behind that you get minus. So plus 3, the factors is this, so you have the zeros is this, so you have the next to the right is plus plus, then behind it negative. And then you have the factor x minus 1, the zeros is 1, so after that is plus plus, then the rest of it is negative. Then x plus 1, your zeros is negative 1, so after the negative 1 get plus plus plus, behind it negative negative. Then do your resultant sign, basically negative negative positive, and then negative 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 positive. Okay, and then this one basically negative 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 3 negative negative plus positive, so negative. Then here negative negative positive, positive positive positive, positive positive positive. Then here positive negative, you're going to get negative, here is positive. So what you want is the part where you have the greater than, so you take plus sign. So you will have your answer as such. For the first part, okay, for the first part, so domain for the first part, you're going to get from negative infinity until negative set 3, union by negative 1 until 1, union by set 3 until infinity. Alright, now are you done? You haven't done yet, because there are two part of it. So there are two part of it. So the first part, you have the x cannot be equivalent. Sorry, I put here it's not equivalent. And the second part is where you have this one. Okay, so two parts. So what you have to do a real number line to find the intersection. Okay, so finding the intersection, so what you have to do is find the draw the real number line, and then you have the smallest number is negative set 3, then comes negative set 2, then negative 1, 1 set 2, and then set 3. So the first part you have is negative infinity until negative 3, so close, so it's a solid. And then continue with negative 1 until 1, so solid, so solid here. And then set 3 until infinity. So this is a part 1. Okay, then the second part, you have this particular part, x cannot be equivalent, plus minus 2 means it is a whole over the two parts, plus minus square root 2, and the rest would be defined. So you just join the two holes. So this is a part 2. So the intersection basically is the part where you have the two numbers over here. Right, this particular part, or if I draw it this way. Okay, so you can conclude the domain for overall. Okay, you're gonna get negative infinity until negative set 3, union by the first part, and then the second part is this, and the third part is this. Okay, so what happens is that you're gonna get the same as negative 1 until 1, union by negative set 3 until infinity. So this is the overall. Again, the domain for composite, I did before, is the domain for your inner intersect with the domain for overall. Basically, domain for inner you got just now is negative infinity until infinity, which if you intersect with the domain for overall, you're going to get the domain for overall for composite. So you can conclude this is the domain for F composite G. Okay, so your final answer. Okay.